Hello. Welcome to the next video in 1.12, Understanding Chance and Data. Let's crack on with Lesson 3. Combining probabilities and probability trees. There are two ways to combine probabilities. That the first way using OR, and the second way using AND. So for example, we can say probability of A or the probability of B, or we could say PA and PB. Let's talk about OR. But in fact, you've already used the OR combination in the Lesson 1 questions when you were calculating the probability of rolling a 7 on 2 dice. You were actually calculating the probability of rolling 1 and 6, or 2 and 5, or 3 and 4, or 4 and 3, or 5 and 2, or 6 and 1. So hopefully you can see why we say probability, the total is 7, rather than 1 and 6, or 2 and 5, or so on and so on. And let's find that original question. Lesson 1 questions. Question 3. 2 different coloured dice are thrown, red and yellow. What's the probability that A? The total is 7. So that's the question that we're working on here. So the way that we wrote it up there, that's a confusing way of writing it. We can write it down better by saying P total is 7 is P of 1 and 6, or P of 2 and 5, so on and so on. It's the same thing, but it's a lot clearer to read. And when combining probabilities with OR, you simply add the probabilities together. So P of A or B is P of A plus P of B. If you had 3 events you wanted to combine, so P of A or B or C, you would have PA plus PB plus PC. You can add as many terms as you want. So for example, the probability that the total is 7 is the probability of 1 and 6, plus the probability of 2 and 5, plus. Because there's only one way to get a 1 and a 6, because there's the 2 dice are different coloured, we can tell the difference between 1 and 6 and 6 and 1. Like, they're 2 different possibilities. So the chances of each one happening is 1 in the total sample space. And the total sample space is 36, which you will know by now. So 1/36 added together 6 times gives you 6/36, or 1/6, which is what you would have worked out before. So this is a more robust way of finding the probabilities of things. If you can do without it and just know that the probability of rolling a 7 is 1 and 6, then do that. But sometimes you'll need to lift the hood, as it were, and understand what's happening with combining probabilities using OR. That's really about it for OR. We'll come back to it later with probability trees, but in the meantime, let's talk about AND. We can also combine events using AND. For example, what's the probability that we roll a 6 and then a 1 by rolling a die twice? So in other words, what's the probability of 6 and 1, but not 6 and 1 at the same time? That doesn't make sense. 6 and then 1. So if I ever say something that sounds nonsensical, like rolling a 6 and 1 on a die, I mean 6 and then re-rolling to get a 1. Or if I say, what's the probability that you draw a card from a deck and it's red and black? Obviously that's going to be 0, because you can't get a red and black card. What I'm probably meaning is you draw a red card and then you draw a black card. What's the probability of that happening? Oh, now's a good time to mention, with or without replacement. So I draw the red card, cool. Do I then put the card back in the deck and shuffle it up, or do I keep the red card off to the side and then draw a card and get a black one? If it's with replacement, if I put the red card back in, then that's a much easier situation. But if I keep the red card out before drawing my, hopefully, black card, we have to deal with conditional probability. Because now we're not talking about the probability of black, which is a half. We're talking about probability of black, given that a red has already come out, which is 26/51. So, different situations, with replacement or without replacement. Anyway, there's a little tangent. We can also combine events using AND for, we just talked about that. There are 36 outcomes. Remember the sample space for throwing 2 dice. And only one way to roll a 6 and then a 1. So the probability is 1 over 36. In general, when combining probabilities with AND, you simply multiply the probabilities together. For example, P of A and B is P of A times P of B. Specifically for the example we were using up here, the probability of rolling a 6 and then a 1 is the probability of 6 times the probability of 1, which is a sixth, and a sixth, which is 1 over 36. So it makes sense based on what we already know, based on we're getting the same answers, but again it's a more robust way of looking at things. Now we can combine the OR combination and the AND combination into probability trees, and they'll give us a way of visualizing what it means to combine events using OR or using AND. We can visualize combining events with probability trees. Probability trees are another way of listing the sample space of a situation. So earlier we were using like a table to list all 36 possibilities of rolling 2 dice, and there was like 1 1, 1 2, 1 3, and 2 1, 3 1, all the way down to 6 6. This is another way of listing a sample space, and it's a really helpful way actually. So it's not just listing sample spaces, but it's so much more than that. For example, construct a probability tree for rolling a die twice. We'll do this in class, and for the first roll we'll do a drawing over here, and then we'll extend it over here to describe the second roll. But yeah, we'll do that in class. When you this will make more sense after we've drawn the probability tree, but we'll go through it now. When you combine probabilities in the same event, for example, like you're staying in the first roll or you're staying in the second roll, you're using the OR combination, e.g. probability of 5 or 6. So the probability of a 5 or 6 in the first row would use the OR combination, which is a sixth plus a sixth equals 2 sixths, or 1/3, either or. When you combine probabilities in different events, you're using the AND combination. So a probability from here and a probability from here, you're using AND. E.g., so for example, the probability that the first roll was a 6 and the probability that the second roll is an odd number is the probability of each multiplied together. So there's a 1 in 6 chance of rolling a 6, and there's a 1.5 chance of rolling an odd number, and multiply them together and you get a 12th, which is not what it says there. Oh dear, I'll update that. Anyway, it should be 1/12. Awkward. On the next page is combining events questions. Some of them are extension, but if you're up for it, I recommend that you give them a go. Actually just give them a go. I mean, and even if you get stuck, what have you lost? Give them a go. I'll see you next time in lesson 4, but until then, see ya.